Everyone, today we'll be focusing on the fundamental counting principle. This is lesson 2 and this is an additional topic in grade 12. You haven't done this part in grade 11. Now you will understand each topic here as we'll be answering the following questions. Now let's begin. So under fundamental principle, we've got factorial notation. We'll be talking about that, and we will be talking about dealing with repetition and selection, 3 of them. So these are the parts that I would like us to discuss today in this video. Now when you talk about factorial notation over here, now it says factorial notation of a natural number is the product of the positive integer less than or equal to n. This is denoted as n and is pronounced n factorial. So this is an example of factorial, the first one, the second, and the third one. Now when you talk about the factorial notation, so let me just show you in the calculator that how do we work this one out in the calculator. When you talk about factorial, we are taking the number, like for example 5, and then we are multiplying this number and going back to 1. That is from 5 times 4 times 3 times 2 and times 1, same in 6. Let me just show you how do we work that from the calculator. You first press the number 5 and you say shift and you press this button here. Factorial is going to give you the answer, which is 120. So it's the same as if you can say 5 times 4 times 3 times 2 times 1. So it's give you the same answer. Let me just use 6 and we check. You first press the number, shift, and this button here, and the answer is 720. Let's check if it's the same. 6 times 5 times 4 times 3 times 2 times 1. Same, 720. Now let's go back to the question. All right, so this is the formula. Let's jump straight to the question. The first question. A grade 12 learner has an accounting, this is the first textbook, accounting, science, Zulu, and mathematics textbooks. Then now they are saying here, how many different ways can they be arranged on a bookshelf? Now this learner has 4 textbooks: accounting, science, Zulu, and mathematics, and they are different textbooks here. So that means this learner is not going to put all of them in one shelf, but this learner have to arrange them. Okay, so now let's just try to analyze here. So that means if we've got 4 textbooks, it means that we've got 4 choices, okay, to select. Then if we've got 5 textbooks, that means we've got 5 choices. If we've got 6 textbooks, that means we've got 6 choices. Therefore 4 textbooks, 4 choices. 4 choices, 4 spaces available. And then 5 textbooks, 5 choices, and 5 spaces available. Okay, now let's begin to check that. How do we go about answering the first question? That is question 1. So in question 1 here, they are saying that we've got 4 choices. We've got 3 choices. We've got 2 choices, and we've got 1 choice here. Okay. Now I was saying that if we've got 4 choices, that means we've got 4 spaces available. So in these 4 choices here that we have, so we're going to select 1 textbook here, and then we put here in the first space. Let me just use a different color. Let me say here we've got space 1. So in space 1, we're going to just choose from these 4 textbooks here, and then we choose one to just want to put it here in the space 1. So from space 1, and again we got space 2, space 3, and space. Therefore, these are the spaces that we have. All right. Now, let me just try to work out this one now. All right. So we're going to say here the number of ways the books can be arranged is equal to 4 factorial, because we've got 4 choices and we've got 4 spaces. Then I'm going to say the number of ways the books can be arranged is equal to 4 factorial. And then let's work this one out so we can use our calculator. So 4 factorial, you first press the number and shift this button, must be 24. So the answer is 24. Remember I said you can also use this one. You can say 4 times 3 times 2 times 1 is the same. Now 4 times 3 it is 12, and then 12 times 2 it is 24. So the answer is the same. Then now let's go to the next question. Question number 2. Now they say 2 different history books. So I've got 2 here, and 3 different geography books. We've got 3, and 2 different science books. We've got 2. Are placed on a book shelf. And the first question here now says how many different ways can they be arranged? Let's count how many in total here. 3 plus 2, 5, plus 2, which is 7. So we've got 7 textbooks here. So if we've got 7 textbooks, that means we've got 7 choices. If we've got 7 choices, that means we've got 7 spaces available. Okay, so let's begin to answer this one as well. That is question number 2. So that is 2.1. So let me also analyze this one. Okay, so yeah, what we're gonna do is that so that means that we've got 7 choices, 6 choices, 5 choices, 4 choices, 3 choices, 2 choices. Because of the space here, let me just try to maybe to cut this one, or maybe we can start here. Let me just say 3 choices, 2 choices, and 1 choice. Yeah, because I want to analyze this part clear. So I said if we've got 7 choices, and that means we've got 7 spaces available. Here we go. Then from here, then we can just conclude by saying, therefore, the number of different arrangements, and then we want to say 7, because we've got 7 choices and we've got 7 spaces, and then we're going to say 7 factorial. Simple as that. So let me just formulate the formula here. Now we said the number of ways the books can be arranged must be 7 factorial, and then we can just check that from the calculator. That 7 shift, there's now 7, it's going to 5040. All right, so that means the answer is 5040. So if you want, you can also use this one, guys. Just use 1. Okay, don't use 2 of them, but I'm just showing you now that any of these correct. Okay, and then is equal, that is the same answer. And then we go to the second question. Now the second question says 2.2, how many ways can they be arranged if books of the same subject must be placed together? So that means now we're going to put the history together, and we put science together and geography. So that means we have to split them. Okay, so that is 2.2. How then do we go about analyzing this one. So let me just use some color. Maybe you can just use this one. So I'm going to write a history, geography, and science. That is history, geography, and science. And then we can also do this, because I want you to understand this part clearly. Okay, because I want to arrange them, and the book of the same subject must be put together. And then that means in history, remember, we've got 2 textbooks. So that means if you've got 2 textbooks, that means we've got 2 choices. So 2 choices and 1 choice. So same here, it's going to be a space 1 and space 2. And same geography, we've got 3, so must be 3 choices, 2 choices, and 1 choice. So we've got space 1, space 2, and space 3. And here we've got 2 here, so that means there's 2 choices and 1 choice. Space 1, space 2. Okay, so this is what we have here. Then from here, what do we do? So from here, that means we're going to say now 2 ways the history books can be arranged. So that means there are 2 ways. As we can see that there are 2 spaces or 2 choices, and here there are 3 ways. So let me just use this color here. So I'm saying that means there are 2 ways, there are 3 ways, there are 2 ways. So if there are 2 ways, so remember we need to arrange. So there are 2, that means 2 factorial, 3 ways must be 3 factorial, and 2 ways must be 2 factorial. Yeah, all right. But and then we need to count the number of the shelf that these books will be arranged on. So how many shelf here? So we've got 1 here, and we've got a second one, we've got a third one. So that means we've got 3 shelves here. So this is the first one, the second one, and the third one. So that means there will be that 3 factorial for the number of shelves, and 2 factorial for 2 history books, and 3 factorial for geography, and 2 factorial for science. So I hope it's clear now. And then now let me just formulate here let me just conclude. Now remember, it's going to be the 2 factorial for history book and times 3 factorial for geography times 2 factorial for science, and then times, let me just use another, then times 3 factorial for the shelf, because the shelf, if we can just count the number of the shelves, so that means there are 3 spaces there. And then we just work this one out from the calculator. And then you can just use your calculator, and then you get the answer as which is 144. Okay, so that was question number 2. Now we go straight to the next question. We've done now with factorial notation. So now let's move on to dealing with repetition. So question 1, given the word probability, so let me use another color. This color is not clear. Given the word probability, or at least this one, let me just use this one, like the same as, maybe this one will be right. Yeah, maybe at least. Yeah, given the word probability. Now in the first question they're saying determine the number of different ways that the letters can be arranged. Okay, guys, let's just go straight to just down there to answer this question. Let me just draw a line first here. Okay, then there is question 1. So question 1, it's under part of dealing with repetition. So it is under dealing with repetition. Okay, so we're given here the word probability. Let me just write this word here. Now let's start. So in the probability, they are saying determine the number of different ways that the letters can be arranged. So what are we going to do here is that we're going to count the letters that the word probability contains. And then we say it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means this word is containing 11 letters, probability. Okay. Then if there is one letter that is repeated twice, then that means we're going to put 2 factorial for that letter that is repeated twice. If there is a letter in the word that is repeated thrice, then we're going to put 3 factorial for that letter. Okay, then now we divide after that, and then we're going to multiply the 2 ones together, and then we divide by the repetition of those letters. Okay, let's just do this one now. All right, so in the probability, then I'm going to highlight this for you. So I was saying that if now we can just count here from P and then to Y, then we can see that B appears twice and I appears twice. So that means going to be 2 factorial for B and another 2 factorial for I. Okay, now let me formulate here. Let me just conclude. Then here we're going to say the number of arrangements is equal to, then we count the total. We count the total number of letters that the word probability has here. So that means how many letters? That is 11 letters, going to be 11 factorial divided by, and then in the denominator we just check the number of the letters that are repeated twice or thrice. So we've got 2 factorial for B and times 2 factorial for I. So this is how we do this question. And then we just use our calculator just to check 11 shift factorial divided by 2 factorial times 2 factorial. So it's 999 200. That is it's 99. Let me just use all right, 99, and then must be 7, 9, and 200. And guys, it's possible that so that you're gonna get the bigger numbers, so don't be shocked. All right, as long as you know the rule and the basic what to do in each question. All right, now let's go to the next question. Now they say we need to, now they say if the word has to start with a B, how many different ways can the word be arranged? If now the word has to start with a B, now let's analyze that one. So that is 1.2.1 2. Well, this is 1.1.2. So this is 1.1. I don't know what I'm doing here. 1.1, 1.2, right? So yeah, they are saying that if now the word has to start with letter B, so that means now we're going to put B, and then we count again all the letters. We count again all the letters, and then letters, the spaces must be 11. So let me just check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me just try to break this. Wonderful. So there must be 11. So yeah, they are saying that if now the word has to start with a B, so that means that B is already fixed. Okay, that B is already fixed. So meaning that if now you are going to do the counting again, the number of the letters that the word probability have, so that means you are not going to count that B because B is already used. That B is fixed. So you have to count the rest now. So that means you are going to count all the letters that the probability has, but except B, because B is already fixed or is already used. Okay. So then I'm going to say the number of arrangement beginning with B. So now the number of arrangement beginning with B is equal to, if now B is already used, that means you are not going to count B, this B as one of those letters there. That means you must eliminate that B. So how many letters now are left? So we're left with 10 letters, so going to be 10 factorial divided by. And then remember in the first question we've used 2 factorial times 2 factorial. So that means we're not going to use that 2 factorial for B because 1B is already used. So we're left with 1B here in the word. So we're going to just divide with only 2 factorial for I, because I is still there in the word. All right, then we just work this one out from the calculator. You can just use a calculator. So I'm gonna get the answers 18,14400. So that is the answer. And then now let's move on to the next question. That is 1.1.3. Then in 1.1.3 they say what is the probability that the word starts with a B? So we want to know the probability of the word start with a B. So what I'm going to do here is that you will remember in the first question here, in the first question we've used all the letters, that means the total. So we can treat this answer here as our sample space. Remember, this is a probability. We can treat this one as our sample space, and this one here, it is a selection of B, or that B has been chosen, something like that. So that means we're going to take this answer here and we divide with this one, which is the one of the sample space. All right, so let's just now say it's going to be the probability, let me just continue using this color, probability of the word starting with a B, is equal to, and then must be this answer here, which is that 18,14400 divided by 9979 200. And then you can just press this one in your calculator, and then you can get 2 over 11, and then which is 0.1818. So that means it is therefore 18%, 18. Okay. And then we are done with this question. Now let's move on to the next question. 1.2, given the word Mississippi, but guys, we're going to apply the same method here in the word probability. So that means I'm gonna just be fast in this question 1.2. So we determine the number of different ways that the letters can be arranged. So we first counted the number of letters that are there, like we did in a probability. So let me just say 1.2. Okay, so we're given the word Mississippi. Alright, so it must be PPI. So this is the word. So let's count, and then we also check the letters that are repeated twice. So that means here we've got S, but S is not repeated twice. So we've got S, how many S? 1, 2, 3, 4. So that means S is going to be that 4 factorial for S. And then what about I? 1, 2, 3 is going to be 3 factorial for I. And what about P? I've got 2 factorial. Oh, there's also that I. Sorry, I didn't see that one. So 1, 2, 3, 4 I. So we've got 4 factorial for I, and we've got 4 factorial for S, 4 factorial for I, and 2 factorial for P. So then we are going to divide with these values in the denominator with this 2 factorial and that 4. Okay, and then on top, remember in the numerator we're going to put the total of all the letters that the word Mississippi there has. And then I'm not going to repeat this, guys. This conclusion here, the one that says B is repeated twice and I and all the stuff. So now I hope you can see. I'm gonna just go straight to the question and answer the question. Then the number of arrangement must be that is going to be the total of all the letters here. Let's check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So for 11 factorial divided by remember there is that 4 factorial for S times another 4 factorial for I times, and then must be 2 factorial for P. And then you just work this one out from your calculator, and then you get this answer is 650. And then that is the first question. That was 1.2.1 and 1.2.2. And then this question says and then this question says if the letter, there should be letter, if the letters of the word, if the word should be word here. Okay, has to if the word has to start with an M. Okay, start with an M. So that means again we're going to fix that M, and then we count the rest. So that means M is fixed now, and then but still up to that level, but now M it is fixed. So it's quite clear, guys, that we're going to, because in total we're having 11, so that means we're going to have 10. But let's just check in terms of repetition. So M does not affect it. So repetition was for S and I and P. So we're going to have the same values that we had in the first question in the denominator. So that means here is going to be, let me just conclude, then is equal to 10 factorial. And then remember, I'm going to repeat those numbers because we're still having those letters there, right? And then the total, can just work this on your calculator, and you're gonna get 3150. Sorry. And then the third question, not like the same as 1.1.3, what is the probability? So we simply the probability, we simply remember this is like the sample space, and then this is like the selection, this one here. So I'm going to take this value and then divide it by this one here. Simple as that. So I hope you understand now. All right, so let me just formulate. So we just take this value, that is 3150 divided by must be 34, and then 650. I have my handwriting, something 50, and the probability is going to be 1/11, which is 0.0909, and then meaning that it is 9.09% of selecting or of starting with the letter M. Right, so let's move on to the last part, which is a selection. We will now use factorial notation to deal with problems where there are a limited number of places which have to be filled from a group. Formula here, let me just write the formula for selection. The formula that we're going to use, it says it's n factorial divided by must be n minus r, then times factorial. So that n r stands for the selection, and then n number of people or spaces available. All right, so now let's look at the first question. Like, how do we go about answering the first question? Question 1, there are 12 contestants in a race. How many different ways can the first one, the second, and the third place be arranged? So how many places have we've got 3 places here, and then we need to fill these 3 places with 12 contestants. So that means we've got 12 choices. So this question is more like the same as the first one. We've got 12 choices, but want to fill in these 3 places here available. So let me just try to answer this question. Do I have still a space here? Oh yes, just let me just draw a line because I'm starting something new now. And then must be question 1. It's under selections. So we'll be using this formula. So I want to write it down here. This must be R, right? So what we're going to do here is that, so let me just write this for you, that in this example, in this question, there are 3 places that have to be filled from 12 choices. Yeah, so that means here we've got 3 places and for 12 choices. So that n stands for the number of choices right there. So that n stands for the number of choices, and r here, there is place or space. So now let me just conclude here by saying the number of arrangements is equal to, that means it's going to be 12 factorial over, must be 12 minus 3, and then factorial. So it's 3 for that place, and then so that means we're going to have 12 factorial divided by 3 minus 12 minus 3 must be 9 factorial, and then we just work out this one. So it's going to give us 1320. That is the first answer. Now let's go to the last one. So I think this is the last one, question number 2, this one. A local running club is holding a fundraising lottery. That is, 4 numbers are to be drawn. 4 numbers are to be drawn from a possible 10 numbers. 4 numbers are to be drawn from the possible 10 numbers. So in the order for a ticket to win, the numbers on the lottery ticket must be in the same order that they are drawn. All right. Okay, then now they say how many different winning arrangements are possible. So yeah, they're saying that there are 4 numbers are to be drawn. So that 4 numbers are to be drawn is the same as, that is 4 numbers are the same as 4 places. And that 10 numbers stands for choices. Okay, so that means in the place of R, we're going to put 4. In the place of N, we're going to put 10, because we've got 10 choices. So simple as that. Yeah, so we're going to do this question like what we did in the first question under selection. So we've got 4 stands 4 places, so that 4 represent R, and the 12 represent N. Okay, and then now we say therefore the number of arrangement must be so we've got 10 here. Okay, so must be 10 factorial divided by 10 minus 4 factorial, and then must be 10 factorial divided by 6 factorial, and then the answer must be 540, and then that's all. I think that was the last question. Let me just double check. Yes, it was the last question. Yes, I hope you understand. Thank you so much for your time.